we see from -2 to -1 what needs to be happening. With our graph.
Decreasing.
We need to be decreasing, right? Now, from -1 to 0, we need to be
Increasing.
increasing. So, if I'm going to pass through the point 0, 0, then I need to get below the x-axis at some point. So, I don't know where I'm going to start from. I'll just start from here, and I'll decrease to here, and then I'm going to come up and increase here. All right, now, where do I stop increasing on this graph? At 3. Where am I increasing the steepest?
2.
At 2. Well, it's kind of 1.5-ish. But
From 1 to 2.
yeah, it's somewhere between 1 and 2. So let me come here. So I'm increasing up to 3. That's horrible. But anyway. So at 3, I start decreasing, correct? No. Yeah, I do. Okay. I decrease starting at 3. Now, what happens when I get to 4?
Constant rate.
It's going to be a steep decrease, but it's going to be decreasing at a, you said the word,
Constant rate.
constant rate. We're going to decrease at a constant rate. So where my decreasing is curved in here from 4 to 5, I'm going to be decreasing at a constant rate. And it's a pretty steep constant rate because it's the lowest I am. I'm still decreasing from 5 to 6, but I'm not decreasing at quite so steep of a rate. Now, what happens from 6 to 8?
It's horizontal.
Exactly. Because my slope is 0 everywhere from 6 to 8. So from 6 to 8, now I kind of have to curve here because it's still differentiable there. So I have to gradually get into it. And then at 8, I start doing what? Increasing or decreasing? Increasing. And I increase up to 10, and I get fairly steep at 10. And then what is my derivative value at 10?
Oh, it does the. It's differentiable, but it's like a. It's a cusp.
It's a cusp, so it's continuous, but it's not differentiable.
Yeah.
Because there is not a derivative value defined there. So it's continuous, but not differentiable. And then I start having negative slopes from 10 to 11, correct? And then I start increasing again. So that's what the graph should look like. So take a second to look at it. Because I'm going to ask a question in just a second. That it's going to be one of those questions that I ask you to think about it with a neighbor. Or the way the class is arranged today, you might think about it with 2 neighbors. So, here's my question for you. You can look at this graph and consider where this graph is concave up, where the graph is concave down, and where the graph has no concavity. Y'all are scaring me back there.
We're figuring out.
Good. Who's got something to share with me on this? So, does anyone have a possible reply here?
You're talking about the intervals of concavity?
Yeah, that's a great question. We are talking about intervals of concavity here. You don't, I mean, things are concave up or concave down at a point, but we usually think of concavity over an interval.
Of the derivative? I mean, well, antiderivative.
Yes. I have to think about what you're asking there for a second. Yeah.
Well, 3 of 5. So, from
Yes.
-2 to 1, it would be decreasing in concave up, and then
All right. So, all right. Talk to me again.
on the interval from -2 to -1, it would be decreasing in concave up.
Hold up. Okay.
And then from the interval, I'm sorry, I can't see it, from the interval of until from -1 to 3, it would be increasing in concave up. And then from 3 to, what would that be, 6?
I don't know. You're telling me.
And then from 3 to, yeah, 6, it would be concave,
Down.
it would be decreasing concave down, and then there's no.
Hold up. Down and decreasing. I'm gonna cut you off for just a second.
Would it be no?
I'm decreasing. All right. You were saying you thought it was 3 to
3 to 8.
3 to
And
8.
it would be not concave.
Okay, from 3 to 8, you're saying not concave. Okay. Okay. All right, keep going. I mean, whoever. It doesn't have to be. In fact, someone else jump in. And you may disagree with something up here. In fact, I hope you disagree with something right here because not both of those are correct. So there's something to disagree with.
What do you think, Margaret?
From 6 to 8 is no concavity.
Okay, 6 to 8 is no concavity. What do y'all think? Okay, you agree with 6 to 8? No, no concavity? In fact, both groups are agreeing with that, because if, so you're thinking just 6 to 8?
Well, I guess finishing up the easy part after.
The easy part. I don't know that any of this is easy.
Well, I'm saying like the part that's a bit more cut and dry from 8 to 10, it is increasing concave up.
8 to 10,
Um,
concave. I'm going to leave off the increasing part, but I will put the concave up part.
And then from 10 to 11, it's decreasing concave up, and then 11 to 12, it's increasing concave up.
Okay. So would I be safe to say that you're saying from 8 to 12?
Yeah, it's all concave up, it's
Okay.
just switching from decreasing to increasing.
Well, here, let me do this. 8 to 10, 10 to 12. Both concave. Because it's not, I will tell you, it's not concave up at 12. Concave, that's,
Well, it's the end.
yeah. Now, y'all did well. I mean, there are some flaws up here. So, again, take out, some of you don't have the worksheet out, but take out the worksheet and look at question 57 again. But this time, don't look at my graph. Now, I will tell you for sure, this is the only thing I'm going to tell you for sure right now, is that y'all, that there is this agreement that from 6 to 8 there's no concavity. And that is correct. Now, looking at that graph in your packet, what is true about 6 to 8?
It's a flat line.
At 0.
As,
On the,
but be more specific than just a flat line.
it's a flat
It
line
has no
on-
concavity?
on the X.
Starts with an A and it starts with an H and sounds like horizontal.
Horizontal.
It's horizontal, yes. Okay. It is horizontal. So because the graph is horizontal, that means that the rate of change is constant. And if the rate of change is constant, then there is no concavity. So having me said that just then, is there something else you can tell me?
Yeah,
Okay. 4 to 5 is also going to be no concavity. Okay.
Would it not be 3?
No,
No,
because
because
it's going
3 is
into
still
the-
moving.
Okay.
And then from 5 to 6, it does have concavity.
Right in there.
All right. So 5 to 6, we do have concavity.
Concave up.
And you're saying it's concave up.
I think so.
Okay. And it is concave up. Now, these things right here are correct. So now you're saying 5 to 6, we're concave up. Now, looking at this graph right here, from 5 to 6 is a little bit hard to tell, but it should be concave up right there. I didn't do a good job of graphing it. It should be concave up right there. But what from the graph that they give you tells you that the graph is concave up? Yes. The slope is positive, so it's increasing. Now, let's think about what concavity is again. When is something concave up from how we discussed it before today? When we did the section on graphing, when did we say something was concave up?
The second derivative, and if you like plugged in a number and it was positive.
Positive, yes. So if f double prime of x is greater than 0, then we are concave up. Now, think about what y'all just said. Y'all said this correct. You looked at the graph between 5 and 6. And I think it was you, Sarah, who said that we were increasing there. Well, think about what that is. This is essentially the graph, the graph they give you is essentially the graph of f prime, right? So if the graph of f prime is increasing, then that means that f prime is greater than 0. I'm sorry, that's not right. The slope of f prime. The slope of f prime is greater than 0. So the slope of the derivative is the same thing as the second derivative. Let me say that again. The slope of the derivative is the same thing as the second derivative. So now I've told you, let's see, 4 to 5, 5 to 6, 6 to 8, 8 to 12. Everything from 4 on we have correct here. So at your desk, see if there's anything we need to adjust between -1 and +4. But don't look at my graph. Look at the graph they give you. All right, so what are y'all gonna tell me here? I'm hoping this is not a tough question, now that we discussed talking about the slope of f prime. Go ahead, Mark.
From -2 to 2.
From -2 to 2.
And then concave down from 2 to 4.
All right, so from -2 to 2, you're saying it's what, concave up? Okay. Now, you're right, but I'm going to call that 3/2 because it looks like it starts decreasing just a little bit. But you got the right idea there. So from 3/2 to what?
4.
To 4, we are what?
Concave down.
Concave down. So, that's again, we're just breaking down a graph and just really digging deep and analyzing it. I usually do not start talking about this until we get into reviewing for the AP test. But I wanted to go ahead and introduce it now because now that I've introduced it, we're not going to look at it for a while. But at least the next time we talk about it, you will have seen it discussed before.